Hi class, today we're going to start chapter 6. This is going to be angles of polygons. Our objectives today are to find and use the sum of measures of the interior angles of a polygon and to find and use the sum of the measures of the exterior angles of a polygon. So you'll notice by our notes we have a big chart, and so let's start off. It doesn't have any space on the note sheet to talk about this, but I want you to just jot up on the top or the bottom blank spot that polygons are a closed figure made up of sides, so line segments, and the sides intersect at endpoints. So there are no intersecting sides here. The two lines come together to make a point. And so let me show you some examples of polygons. So go ahead, just drop those down. Squares, we have a little diamond shape here, stars, and we'll see some other ones. And these are examples that are not polygons. Notice how some of the shapes are open, or we have our shape here where our sides intersect. That's not a polygon. That is going to be two polygons. So let's go ahead and jump into our chart and you'll see what I'm talking about. Here's our first chunk of the table. So what is this polygon? We all know that this is a triangle. We just finished triangles in chapter 4. Number of sides, so if we count that up, there are 3 sides. And the number of triangles, there's 1. And this seems like a silly thing, but it'll make more sense when we get to the other sections on our note sheet. Sum of interior angles. Well, we already know that interior angles, if we add up all 3 angles inside the triangle, that's what the word interior means, that those are 180 degrees. All right. The measure of regular interior angles. So this means if this is a congruent angles for all of them, that's an equilateral triangle. The measure of our interior angles we know is 180. If we divide it between our 3, that gives us that 60 degrees. All right, the measure of regular exterior angles. So when we talk about exterior angles, if I extend these lines out, we've just created some exterior angles. We have one there, one there, one there. Excuse me. So if we take those, we know that our inside angles are 60 degrees, and that the 60 degrees is here, and that the 2 angles together is going to be 180. So to find that exterior angle, if we take 180 and we minus that 60, we get 120 degrees. Okay, and now we're going to just talk about those exterior angles. All 3 of those exterior angles, if we add those together, or in this case, we know all the exterior angles are 120. Let's just take 3 times 120. 3 for the exterior angles, because there are 3 of them, and 120 for the exterior angles because they are 120. We know that our exterior angles are going to add all up to 360 degrees. All right, let's jump to the next part. All right, this polygon here that we're going to be looking at is a quadrilateral. Quad meaning 4 sides. All right, so that's where we can put in 4 right there. And that says number of triangles, which seemed like a silly statement in the last part. But if we look here, I can break a quadrilateral into 2 triangles. And here's where that comes into play. The sum of the interior angles. We need to figure out what the sum of the interior angles are. Well, if I have 2 triangles, and I know from my previous portion of the table that each triangle has an interior sum of 180. So here I can take 2 times my 180, and I find that the sum of my interior angles of a quadrilateral is 360 degrees. All right. Measure of regular interior angles. Here, we're going to be talking about something that has 4 congruent interior angles. So we just saw that the sum of the interior angles is 360 degrees, and there are 4 angles that we have, and so each of those angles is going to be 90 degrees. Using that knowledge, we put into play here with our picture. If we look here, we're going to create some exterior angles. I have an exterior angle there, 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 and there. So 4 exterior angles. I know that each interior angle is 90 degrees, and my interior angle plus my exterior angle is 180 degrees. So if I take my 180 degrees and minus that 90, that interior one, I find that each exterior angle ends up being 90 degrees. Or I have 4 exterior angles, and they are each 90 degrees, so the sum of my exterior angles is 360 degrees. All right, let's jump to the next portion. Here we see a polygon, and we look at this polygon and count up the sides. We have 5 sides, and 5 sides is a pentagon. All right, number of triangles. Let's go ahead and draw in some triangles here, split up our figure. We see we can have one on the top there, and then we can split here, and there we have 3 triangles. All right, so 3 triangles, and we know each of those triangles, sum of their interior angles is 180. So if we take 3 times our 180, we find that our pentagon has a sum of 540 degrees. All right, so if we say that every interior angle in this pentagon is congruent, we know that their sum is 540. If we divide that, we have 5 angles here. We know that each of those regular interior angles is going to be 108 degrees. That again comes into play here in our picture when I extend out my sides of my polygon, or my pentagon, excuse me. And we look here, we have some exterior angles we're going to be talking about. All right, so we know that my exterior angle and my interior angle equals 180 degrees, and I'm going to subtract out that regular interior angle of 108, and therefore I know that each of my exterior angles is 72 degrees. So there are 5 sides, and or 5 angles, I should say, and each of those is 72. So we know that the sum of our exterior angles is 360 degrees. You should be seeing some patterns emerging here. And let's go ahead and look at our next polygon. Here, if we look at this next polygon and we count up those sides, we see there are 6 sides, and this is a hexagon. All right, in my hexagon, I can break this up and I can create 1, 2, 3, and 4 triangles. We know each of those triangles is going to have a sum of their interior angles to be 180. So we have 720 degrees is my sum of my interior angles for my hexagon. Now, if each of those angles were congruent, so I'm just throwing in some congruent markings, we know that they're 720 degrees. If I count it up, I have 6 angles there. And if I divide 720 by my 6, I know that each of those regular interior angles would be 120 degrees. This helps us out when we look here at our exterior angles. All right, there we go. We know that each of these exterior angles that are getting marked in blue now, and if we add them to our interior angles, which are there, they have a sum of 180 degrees. We're going to minus out that 120 degrees, and we're going to find that each of those exterior angles is 60 degrees. There are 6 exterior angles, and they are each worth 60 degrees, so the sum of my exterior angles is 360. All right, so do you see patterns emerging here? Well, in this portion here, we're going to put those patterns, and we're going to make them into a generic form. We're going to call my next polygon, which we can't draw because we're writing in a generic form. We're going to call it an n-gon, meaning it has n amount of sides. N can be anything. I can plug in 3, then this becomes a triangle. If we plug in 4, it's a quadrilateral, etc. Okay? So my number of triangles, well, if I go back and look at my previous slides, here I see my number of triangles is 4, my number of sides is 6. My number of triangles is 3, my number of sides is 5, my number of triangles is 2, my number of sides is 4, my number of triangles is 3, my number of sides is, my number of triangles is 1, my number of sides is 3. So if we go ahead and put that here, I know that my number of triangles, if I was paying attention, was always 2 less than my number of sides. So we're going to call that n minus 2. So my sum of interior angles happen to be 180, we took 180 and we times it by something every time. When you look back at your chart, you times it by the number of triangles there were. So here I see my number of triangles is represented as n minus 2. So we call this 180 times my n minus 2. n minus 2, remember, is my number of triangles. All right, now if we look at our measure of interior angles, if you look back there, our measure of interior angles, my top number always was my sum of my interior angles. So my sum, oops, excuse me, miswritten there. My sum of my interior angles, and we always divided it by, well, what did we divide it by? Look back at your chart. Do we divide it by the number of triangles or the number of sides? It was always divided back by the number of sides. All right, so the last portion, my measure of regular exterior angles. Well, if you looked at that bottom section, every time it equaled 360. So it didn't matter how many sides I had, I knew my sum was always 360. So if I want to find the measure of each individual one, it's going to be something with my 360. Well, I'm going to jot down here, exterior angles always add up to 360. Now, I want you guys to see if you can come up with some type of formula we can put in there for tomorrow. Now, go ahead and take a look at your back portion of your sheet. And I just copied over that polygon information about the n-gon. I want you guys to come tomorrow with the back side tried out. The front side is a lot of information. See if you can put it to use on the back side, and we will see you guys tomorrow.